Assalamualaikum and a very good morning. Today I want to present my final year project with the title of Heat Diffusion of 2D Square Plate using Finite Difference Method with Steady State Solution. And the objective of this project is to solve the 2D heat equation using Finite Difference Method. And secondly, to use MATLAB code to solve the 2D heat equation materials. Thirdly, to get the solution of diffusing the heat inside a square plate with specific boundary conditions and initial values. And the fourth one is to solve the steady state temperatures of the plate and time taken for the plate to reach the steady state. And for the methodology, the rho here is the material density, Cp is the specific heat, and the capital K is stand for the thermal conductivity. And this one is the boundary conditions. The boundary condition is different for each problem. We have 4 problems here. And this one is the grid for discrete the plate temperatures and convert the heat equation into a finite difference form. Okay, this is the notes. And this equation, this is the governing equation, and the equation we get from the equation 3.4 we get here is from here, the horizontal one, the 3 horizontal one, and then for the delta y we get from here, from the bottom to the top here. Then we get this equation, and then after that we get the 3.10 equation after multiplying the delta t with the alpha, and then we combine the same t, and then we factorize the pkij, and the final equation is 3.16, and this is the stability conditions. For the result, we get the result because we get the result. And this is the result for the problem 1, where the same initial values and boundary conditions. And the problem 2 is different boundary conditions but the same initial values. Problem 3 but with the different initial conditions and the same boundaries. And the fourth one is using Euler method and using the Range-Kutta method. Okay, I will show you how to get the result by using the MATLAB. Okay, firstly we need to insert the material here. We need the I insert the aluminum and insert the parameters here, and then this is for the boundary conditions here. Boundary condition will change for the difference problem, and the t initial for the initial values, and this is the time step. And then the tolerance is different, but I use the same tolerance for each of the problem. And then if I run, and it will appear either I want to use Euler or second order Range-Kutta. If I use Euler, it will appear on the spot like this. And this is the result will show when is the plate reach the steady state. And for the aluminum plate that I choose is reach 2798 seconds. The steady state of the plate is different due to the materials, and the boundary conditions also the initial conditions that we apply. In the conclusion, we can conclude that we study the finite difference method for solving the 2D heat equation on a 2D plate. And we apply the parameters of the plate and many different boundary conditions with the Dirichlet conditions. And then the project solve for the plate stable state temperature as well. And it also shows that the MATLAB code can solve the finite difference method, and yes, can solve the finite difference method. That's all from me. Thank you very much.